Good afternoon. I'm Pat Fitzgerald with New York State Energy Research and Development Authority. Thanks for joining us for today's session. I'd like to highlight the information that will be shared. We'll be talking about awarded projects through NYSERDA's Buildings of Excellence Design Competition. The first project we'll be hearing from is The Rise by Zenith Partners and Magnuson Architecture. The second will be the 76 project by South End Development and Garrison Architects. And the third will be the Park Avenue Green project by Omni New York and Bright Power. All exceptional examples of projects awarded through our Buildings of Excellence Design Competition. I'd like to give you a brief overview of that competition. The Buildings of Excellence Design Competition aims to accelerate the design, development, construction, and operation of carbon neutral buildings, or gut rehab, or change of use of buildings that meet the following criteria. We're looking for proposers to present projects at an early design stage that exhibit architectural and urban design quality and innovative solutions that are capable of withstanding increased risk and impacts associated with future climate change. We'd like to have projects demonstrate to us how interest in and demand for carbon neutral and climate resilient buildings will be enhanced, and also ask that they assess and propose reductions to embodied carbon in their proposals to NYSERDA through this competition. We're asking projects to commit to sharing information at a level that's not typical of projects that are engaging with NYSERDA. We're looking to focus on the project's design, cost, and performance. We'll talk about that in a little bit more detail. And also, I just want to highlight that we give additional consideration to projects that will achieve energy affordability and serve disadvantaged communities. The Buildings of Excellence competition is an exclusionary competition looking to identify truly the best of the best examples of projects that meet those criteria, and the additional award NYSERDA offers for those projects is up to $1 million in direct funding. And we're also interested in providing support that would help them to broadly market their projects and increase public awareness of the solutions that they're leveraging. The nature of information sharing relates to project cost data. We're accumulating at a detailed level that information and publicly sharing it. The data is published on our website, and we're updating the information on a monthly basis. We will ultimately be completing very detailed performance validation of projects as they're completed, working with project teams that are benchmarking the performance of the buildings. We'll produce case studies of the projects to help tell the story about what worked and possibly what didn't. And we're inviting channel partners to work with us to promote the projects and also to do independent analysis and leverage the data that we're accumulating for these projects. Just to highlight the projects that did participate in the first two rounds of the design competition, and we anticipate at least one more round of the competition being released this fall, so stay tuned for that. But the first round, we awarded 28 projects. All projects were proposed to rely on electric space conditioning, although some continued to use fossil fuel for domestic hot water production. As you can see, of those 28 projects, 68% of them were LMI, or low to moderate income. Round two of the competition, we selected 14 projects, and 78% of those projects were LMI eligible. All projects in round two are meeting our definition of carbon neutral, fully electrified for all end uses, but for emergency generation, and really exceptional projects across the state and across market sectors, from low-rise garden-style apartments up to super tall. I think the tallest building we have is a 48-story luxury apartment building. All exceptional projects that we'd like to talk about at some point. And with that summary, I'd like to invite all of you to listen to an introductory video about the Buildings of Excellence competition that emphasizes the kinds of projects that were selected and awarded through round one of the competition, and interviews from those project teams.
There's a saying to leave the campsite better than you found it.
We want to build a building of the future. We want to build buildings that are going to be cutting edge.
We don't just have to reduce the amount of energy that we're using, we actually have to start going negative. We need to actually start taking that carbon out of the atmosphere.
This is doable, it's sustainable, and it's replicable. 2050 Grand Concourse, located in the Bronx, we broke ground last year, October. It was important for us to be a part of designing a building that will bring back the Bronx. The Bronx is booming.
It's a no-brainer. This is the way the industry is going.
There's so many people going to sleep without proper heat, and this is a way that you can give people thermal comfort and filtered air.
This is a 96-unit apartment community, family project with 1, 2, and 3-bedroom apartments.
One of the benefits is to get off the use of fossil fuels and is taking the first step to building electrification that will really be able to work off the technologies of the future.
Sendero Verde is a 3-building, 800,000 square foot, 100% affordable housing project in East Harlem. It has a really robust community facility.
Linden 2 is out in Lindenwood, Brooklyn. It is an 8-story, 160-unit multifamily building, 100% affordable housing.
The challenges are very typical of any other type of project, but if you have the right team, you're able to overcome them.
In designing a green building, sometimes the upfront cost is more. Contractors present items that are cost effective. We had to make a decision to push back and stay true to our design.
One of the challenges going into this is we're going to have to find contractors who are willing to be trained to build this kind of construction.
I think it's great to see us finally embracing new technology for the better.
I hope that builders, developers actually start thinking diversity and inclusion, and that's all part of our responsibility in this industry.
What I really hope is that we can move high-performance building from something that's like only achievable for a very small percentage of people and really move that and make it part of the mainstream.
Housing is a basic human right.
We're looking towards more vibrant, even stronger, even healthier and more equitable neighborhoods and communities. And I'm thrilled to be a part of it.
I feel very connected to something greater than myself. You know, we have a statewide climate initiative that's trying to really solve a big problem that the world is facing.
The Buildings of Excellence Award is great because it's incentivizing other architects to really be pushing the envelope forward. I'm really excited to see what happens in the next 30 years.
Hi, I'm Chris LeBron, Director of Design and Construction for Zenolith Partners. We are a WBE developer of affordable housing based in New York City. Today, I'll be talking about The Rise, our project that recently won a NYSERDA Buildings of Excellence grant, as well as a Blue Ribbon for Design Excellence award from NYSERDA. The project architect is Magnuson Architecture and Planning, and the sustainability consultant is Bright Power. The Rise is a mixed-use affordable housing development in Brooklyn, New York. It is primarily supportive housing for formerly incarcerated individuals and their families, and will have a very large community facility with on-site supportive services and extensive programming focused on health, wellness, and community empowerment. This is a state-owned site awarded through a competitive RFP process as part of the Vital Brooklyn initiative. Vital Brooklyn is New York State's comprehensive community development strategy aiming to address the social, economic, and health disparities in central Brooklyn. There are 8 integrated areas of investment outlined here, and RFPs responding to this initiative had to address some, if not all, of these investment areas. The context map on your right shows where central Brooklyn is in relation to New York City, and the star indicates where the project is located in the Brownsville neighborhood in central Brooklyn. And this is a neighborhood that has a disproportionate share of challenges across the board. As you can see, this is an innovative and holistic approach to community development, and we're starting to see other agencies replicate this model. In terms of the RISE, our specific project goals are to foster stability, health equity, and community resiliency. And we do this through programming and design. In terms of programming, as I mentioned, there's a dynamic community facility with 6 local operators providing programming in most all of these investment areas for both building residents and the broader community. And in terms of design, for this particular population and this particular project, we're using trauma-informed design, which Julie will talk a little bit about in a moment, active design, design for health and wellness, and of course, sustainable design, in this case, a fully electrified passive house building. So why passive house for the RISE? Well, fundamentally, Zenolith is a purpose-driven developer committed to building thoughtful and sustainable buildings that benefit communities and residents. This was a health and wellness RFP, so we asked ourselves, how do we create the greenest, cleanest, and healthiest building possible? And we think that answer is passive house. We are finding that passive house is a more competitive concept for public financing, which is critically important in affordable housing development. And we're seeing that increasingly across all agencies, this is becoming more and more a priority. Of course, we want to capture long-term operating savings, and we want to capture as many incentives as we can for sustainability, and NYSERDA's BOE grant is just one of those. Finally, we really think it's part of best practices and the future of building in New York City and beyond. We are fortunate to have an aligned architect on board that shares our values and the project vision here. And it's really critically important to form the right team when you're trying to achieve a successful and impactful building, especially one that's complex. And with that, I'm going to turn it over to Sarah Beyer, MAP's Director of Sustainability, for a deeper dive into the passive house piece.
Hi. The RISE is certainly a part of an industry-wide shift towards a higher performing standard. We are tracking this across our portfolio, which you can see in this approximately 10-year plot of our project source EUI with our 7 BOE projects highlighted. The site EUI of those projects are also indicated. Our experience is that the decision to move from business as usual in affordable housing to passive house is easier because these publicly financed buildings are already required to be more sustainable than most code-driven multifamily buildings. They already must meet the energy threshold of enterprise green communities, which traditionally does not have a dramatic baseline energy requirement, usually 15% cost savings below code. Yet it nonetheless has given large groups of people in our affordable housing industry the tools, knowledge, and confidence to incorporate the next generation of energy efficiency measures. This has influenced the wider construction market. The reasons that we see our developer partners moving then to passive house are as Chris has described. The benefits are integral to their mission and goals. They hold on to their assets longer and therefore value the energy savings, and strong agency support cannot be overstated. As an industry, we are now truly discussing and developing solutions to address embodied carbon, which is imperative. Embodied carbon is a primary focus because minimizing emissions over the next 10 years or so are critical to backing us off of climate tipping points. In a business as usual scenario, embodied carbon would account for half of new construction emissions in this time period. Here are the current strategies we are thinking about as a firm when we look to reduce a project's embodied carbon. The RISE is also incorporating some of these concepts. Because we are a purpose-driven architecture firm, our approach centers around quality and design as a way of helping our clients achieve their missions. We view the passive house strategy as central to accomplishing this, and we have integrated it into the very DNA of our sustainability approach as described here. The passive house community will recognize these 5 principles. Once we start implementing the first 3 that come directly from the standard, we can unlock the potential of the subsequent principles. We emphasize during design that resources spent on one will make others less costly to achieve. All five are essential to be woven together to create the fabric of healthy, durable, resilient, and efficient buildings, such as the Rise. Now, Julie Chu, Senior Associate and Project Manager of the Rise, will give you a deeper dive into the project.
Thank you, Sarah. So here at the Rise, we are able to achieve the programmatic goals to address the health and well-being of the residents, as well as the principles that Sarah just mentioned through our design. The Rise is a 7-story building that is generously set back at the main facade to create a landscape space at the street level, as well as at the top 3 floors with landscape terraces fully accessible to the residents. The main roof functions as an urban farm and is open to both the residents and the community. The abundant greenery also includes vine-clad exterior walls, and altogether, these elements provide a strong connection to nature as part of trauma-informed design, and as a result, create a calm and welcoming space for our residents. Here, the typical floor plan shows an efficient layout with stacked units to provide a total of 72 apartments. Half the units are studios, and this is one of the reasons we're going for a PHI certification, which has a density calculator to account for the large amount of studios. You can also see here that windows are provided at the end of each corridor to provide natural light to minimize energy usage. The setback for the north facade, which is important to our design, creates a little complication for passive house detailing. However, the rest of the residential portion of the building is a very simple layout that allows for an efficient envelope as well as minimal ductwork and piping. It's important to note that we are only certifying the residential portion of the building. However, we carry our principles throughout all spaces. Here you can see the community facility at the ground floor and cellar highlighted in yellow, which provides meeting rooms and exercise rooms for the residents and larger community. You can see in the plan that most of the ground floor is lined with storefronts, which have steel beams above to provide for the large openings. All the community facility spaces are provided with ERVs, and we have provided louvers at the storefronts for the supply and exhaust. Currently, the thermally efficient frames for the triple pane UPVC storefronts do not have an integrated louver, and we're looking at providing an aluminum louver instead. As Sarah mentioned, one of our primary goals is to provide a robust thermal enclosure, and you can see our list of strategies here to achieve this. Part of the challenge of the Rise is providing for so many accessible roofs and terraces, and staying under the 75 feet maximum building height and providing the required 8 feet headroom below the terraces. While we would love to use mineral wool at our roofs, in order to achieve the R50 insulation value here, we're using a newly developed XPS insulation with 80% lower embodied carbon than previous XPS. Another thing to note, by certifying the residential portion, the window wall ratio is only 24%. If we included the community facility spaces, then the total fenestration for above grade walls would be 35%, which is another reason why we're not including the ground floor as part of the certification. For energy efficiency, we're reducing the carbon in the operation of the building by going all electric with heat pumps for mechanical heating, cooling, water heating, and laundry. Currently, New York City zoning only allows a PV array size 25% of the roof if you have maximized the building height and are trying to provide an occupiable roof. With this size, we're able to generate roughly 27,000 kilowatt hours, which will be able to roughly offset about 5% of our energy usage. We think that changing the zoning resolution here would be a significant help to projects like the Rise. With an airtight thermal enclosure, we are even more careful to provide healthy indoor air quality. Here we provide the balanced filtered fresh air through a centralized ERV system. We're anticipating the day when providing this is code minimum. We also recognize that in recent years, better data has been recorded as to the long-term health effects of the chemicals we use in modern society. This has inspired the creation of a separate field of, quote, green chemistry. Currently, there's more than 85,000 chemicals in commerce out there. However, the EPA has only regulated 7. So for the Rise, we're calling for all products to provide health product declarations if they have them, and are aiming for certifications from our largest material quantities, such as the flooring and drywall. Fortunately, materials that are better for ecosystems and human health during manufacture, construction, and occupancy often also use less embodied energy. There's quite a lot of low-hanging fruit here. The first one being to simply ask for transparency in your specs by asking for environmental product declarations for your product. Additionally, we strive to eliminate all plastic installation in this project. We are also looking for high recycled content and products that can perform multiple functions such as foam, glass, gravel. Other key concepts are reducing the cement and concrete, getting steel from electric arc furnaces, and using carbon neutral flooring. We're also looking to recycle our construction waste and extending our strategy into the operations of the building, providing refrigerant leak detection. This detail here shows our accessible roof terrace with the roof plank dropped 12 inches to provide room for the insulation and paver. The Irma roofing here allows us to have a consistent thickness of insulation at our roof since it doesn't require the insulation to be papered. And with the membrane at the bottom, you have room to return the flashing up the wall, and that allows our storefronts to meet the floor. At the parapets, we're using autoclave aerated concrete to connect the insulation of the wall and the roof. ACC is essentially a concrete with about 1/5 of the material with entrained air that gives it about an R value of 1 per inch. At the storefront saddle here, we're using a high PSI thermal break material that provides an R value of 0.95 per inch. So the Rise has an EUI of 21.1 kBTU per square feet per year. With the current code resulting in 90 EUI, the Rise is more than 4 times as efficient. It is also under the PHI primary energy certification requirement of 23.3. In conclusion, we're really excited that we're able to achieve all of this and at the same time provide a beautiful, welcoming building with large windows, abundant natural light, ample outdoor green space, and healthy and attractive finishes to help our residents heal, grow, and transform their lives. Thank you so much.
Hello, my name is Corey Jones. I'm the founder and CEO of South End Development. Thank you for allowing us to share our Passive House project with you. The project name is 76. We're genuinely excited to be able to provide the people of the South End of Albany such a great and improved place to live. I grew up in this same neighborhood. I understand the challenges that underserved communities may face. I didn't have a warm house to live in. Oftentimes our electricity was turned off, so it would get freezing in the wintertime and extremely hot during the summer months. For much of the year, my brother and I would either be too hot or too cold. I don't ever recall being comfortable as a child living in the South End of Albany. We also had such a small place to live. It was always seemed like someone was smoking. All you can smell is the cooking of the neighbors. We just thought it was normal. I can remember this was mainly because we didn't have much to eat, so smelling the food next door was always a hard thing to deal with. My brother and I were wards of the state of New York and put in foster care in the South End of Albany at an early age. Often our foster parents were addicted to drugs and were left to fend for ourselves. We didn't have clean water. We didn't have clean food. Didn't have a safe place to play. Didn't have a safe place to go out. It was a dangerous place to live. I wanted to share why I feel so strongly about passive house design. What led me to design a much more efficient, safe, and overall healthier and stable living environment for the neighborhood I grew up in. Thank you for allowing us to share our passive house design. Now I hand it over to our lead architect, Professor James Garrison.
Okay, thanks, Corey. Hi, everyone. I'm Jim Garrison with Garrison Architects. I'm here representing our team of engineers and designers who have worked through the development of the 76. That includes ME engineers for mechanical, biohabitats for water systems, Energy Link for alternative energy generation, the Chazen Company, who are civil and structural planning, and the Levy Partnership, who have worked through the energy modeling and the passive compliance of the building. So the 76 is the most dramatic development of our project to combine passive design principles and prefabrication over the last several projects, reaching back quite far. And we're very pleased that we've been able to hit thresholds that we thought previously we probably would never hit. The 76 is an urban area in Albany. It is a historically disadvantaged area. You can see it's next to the New York State Capitol, next to the Hudson River. It's on a hillside overlooking the river. It has a lot of open space, a lot of demolished buildings. It's a tough neighborhood, and the red trapezoid is the location of the project. There are several urban influences that have generated the project shape, but you can see that much of the project is defined by Corey's values and what he's hoped to accomplish in this neighborhood. And they include the idea of zero impact development. That is this triple net zero proposition where we create all of the energy, we cleanse all of the water, and we are responsible for all of the waste that goes through the building to make sure there is no landfill contribution and we minimize it. But in addition to these energy pieces, this is an integrated bit of design that includes limited equity ownership of the apartments, units that allow for different kinds of lifestyles, that allow an elderly parent or a child to remain independent or become independent. Urban agriculture, basically growing throughout the building, on the balconies for aquaponics, which combine fishery and garden, and of course distributed infrastructure, which this represents generally. The idea that the markets around the farms around the area will contribute directly to fresh fruits and so forth in the building. Passive design principles, which in our case include the control of solar energy at the building's facades, large volume buoyant air ventilation systems, and very carefully controlled insulation levels. And of course, we also have the urban transportation components that are part of any urban site. This is an image of the building, and you can see that the building uses greenery, photovoltaics, single-axis rotating arrays on its rooftop, all of which contribute to generating adequate energy. The arrays on the rooftop include a solar thermal component, which is the energy from which is stored through seasonal geothermal wells. Another image looking up the hill. And finally, an image from the rooftop of the 76 looking out over the Capitol to the right, and people hanging out under these photovoltaics so that are in a constant dance over the course of the day and make spaces that people can inhabit underneath. So from here, Jordan is going to take the reins and take us through some of the details of the energy systems.
Thank you, Jim. Hi, I'm Jordan Denz with the Levy Partnership. We are a building energy sustainability consulting firm in New York City. This diagram shows the overall energy management for the site, including sources and sinks of thermal and electric energy. About 3,200 megawatt hours of thermal energy will be drawn from solar thermal, the ground, and the heat pump recovery system. About half of this energy will heat domestic hot water, with the balance going mainly towards space conditioning of the common and commercial spaces and the pool. On the electric side, we're anticipating about 2,500 megawatt hours from solar energy, which goes towards apartment space conditioning, plug loads, appliances, the water treatment plant, and pumps. This kind of diagram is useful in that it can depict the overall flows of energy throughout a site, especially when we're trying to hit net zero. The next slide shows our net zero water goals. EPA's definition of net zero water is limiting the consumption of water resources and returning it back to the same watershed so as not to deplete the resources of that region in quantity, or quality over the course of the year. Our zero water goal will be met by reducing the load on Albany's water and sanitary systems with rainwater, stormwater, gray water, and black water treated and used on site. We'll be managing and storing stormwater on site to prevent discharge to the storm sewer during peak flow times and not exceeding pre-development runoff volumes. Because of limitations to the size of the site, we can't supply all of the project's water and treatment on site, but the proposed water cycle approach will discharge only clean water to the wastewater treatment plant and storm sewer to not contribute towards combined sewer overflows into the Hudson, and will reduce withdrawals from the watershed and associated energy and environmental costs of doing so. The diagram illustrates the proposed approach. We'll utilize water-efficient fixtures throughout, harvest rain and stormwater to supply all site and gardening irrigation, the commercial laundry, and the commercial toilet flushing. We'll be treating wastewater generated on site and reusing it to supply water for residential toilet flushing. And we'll use municipal water for domestic water use, residential laundry, and fire suppression. The third pillar is no waste. No waste generated from the 76 by either the residential or the commercial uses will go to landfills. This goal will require a combination of recycling, composting, reuse, and converting solid waste to energy. And of course, this will take a mindset and a culture change as much as it's going to require architecture and mechanical and other systems. So we've evaluated a range of options for on-site waste mitigation, including composting, incineration, and the bioreactor. And given the project density, space limitations, and regulations, the resulting plan will use and engage some local partners, outside partners, selected to mitigate transportation emissions. And this will result in 2/3 of the waste being processed within 1 mile of the site or at facilities constructed on site to support the project. And as you can see in this diagram, there are 3 primary flows of waste, each being managed by a separate outside partner, that being compost, recycling, and other waste that must be incinerated to produce energy. So this summarizes the triple net zero goals of the project, and it's been a pleasure to present them to you today. Thank you.
When the Department of Transportation removed development restrictions off of Maria Lopez, a 200+ unit Section 8 property in the South Bronx, the owners of Maria Lopez, Albany, New York, had the opportunity to build 300+ affordable units as of right on a vacant piece of the property. Since these were going to be Omni's first 2 ground-up buildings, they really wanted to challenge themselves. For the first building, Morris 1, we committed ourselves to building a LEED Gold building. And when it came time to build Park Avenue Green, we decided to push the envelope and commit ourselves to building the largest affordable passive house in North America. When the projects were complete and the certifications were in hand and in conversations with the Bright Power team, we realized we had a unique opportunity. We have 2 buildings of almost exact same size on basically the same lot with similar programs, the same ownership, the same property management team, and almost identical PV and cogen setups. It was the perfect laboratory to study the real-life performance of a passive house versus an industry standard LEED building.
Hi, my name is Avery Gray. I'm a senior project manager at Bright Power, and I'm going to give a brief overview of the passive house design for the project to provide a little bit of context for the discussion of the monitoring and the Buildings of Excellence Award project. So here's some images of the siting. Project is located in the Bronx. On the right-hand side, you can see a satellite image. The project in question is on the top there. 2 phases, as had been mentioned. On the right-hand side is the Morris Ave Apartments, which was the earlier phase 1, more typical construction. And on the left-hand side is the passive house certified Park Avenue Green Apartments. Here's just a closer up sighting of the 2 buildings and connected Parking, that was part of the phase one. You can see a lot of similarities between the two buildings beyond having the same ownership, and a lot of design characteristics that make it really interesting to have this monitoring study for. Here we see the first floor entry on the left-hand side and the cellar plan on the right-hand side. A pretty typical approach for New York City mixed-use building. Residential floors above, community facility space that's non-residential on the ground floor, and the cellar and ground floor space have main entry lobby and some mechanical and back-of-house spaces supporting the residential services. Worth noting is that the certification and pass house design did not include the non-residential community facility space. This shows a typical floor plan and unit mix. So interesting or worth noting for this design is it's not too dense of a project with a lot of studios. It's a good mix, double loaded corridor and somewhat of a complex envelope and a lot of exposures on all orientations. Here is a typical section through the building showing EAF system throughout the majority of the envelope with a brick at the ground floor, continual exterior insulation, continuous insulation below grade, below slab, and a minimum R50 polyiso at the roof, and continual insulation around parapets, typical treatment to minimize thermal bridging throughout. Typical details of the window assemblies. The windows here are triple glazed UPVC throughout with a U value of installed 0.16. And the building systems, their VRF system for heating and cooling throughout the building with ductless indoor units. The design team reviewed early on centralized versus decentralized ERVs and decided to have decentralized unitized ventilation ERVs throughout in each dwelling unit. You can see an image here during construction. And the project also included a combined heat and power, a CHP system that provided emergency power and also reduced demand for the domestic hot water system, and a solar array on the roof. So that is a brief summary of some of the design aspects of the building related to the passive house design. And now Matt is going to give a description and go into the details of some of the results on the monitoring.
Hi, everyone. My name is Matt Murphy. I manage the Mobius team at Bright Power. Mobius is an annual subscription service that combines real-time energy monitoring with a dedicated project engineer to decrease energy consumption and increase operational efficiency through a find, fix, follow methodology. Our approach to this project is fairly unique since we're monitoring the Passive House certified Park Avenue Green, as well as the neighboring Morris Avenue apartments, which is of similar size but more traditional construction. By installing sensors and monitoring similar equipment and data points at both buildings, we're able to compare and contrast key performance metrics related to Passive House, in addition to hopefully reducing energy consumption at both sites. These are just a few of the things we're monitoring at these buildings. Both properties have similarly sized cogeneration plants, as well as rooftop solar arrays. Here's a quick look at the boiler room line diagram at Park Avenue Green, which is usually how we start identifying what equipment and points we want to bring into our monitoring platform. Park Avenue Green is equipped with unitized ERVs that provide balanced ventilation to all apartment units. There's also a much larger ERV on the roof that sends fresh air to, as well as exhausts the corridors. Heating and cooling is achieved through a Mitsubishi VRF system. We were able to integrate with the existing controls to extract apartment temperatures and usage data on the indoor and outdoor units. This will help us determine the efficiency of this system when paired with passive house construction. This is a high-level total energy usage comparison for the full year 2020, comparing Morris Avenue apartments and Park Avenue Green. We provide much more granular insight to the building owner regarding energy consumption, including weather-normalized seasonal usage. However, this basic comparison is really powerful when comparing passive house to traditional construction. Major focus for us is indoor air quality. The next few graphs are screenshots from our monitoring platform showing trend data over about a week. For the rest of the slides, the orange data represents the traditionally constructed Morris Avenue apartments, while the blue data is from the Passive House certified Park Avenue Green. Humidity control is a key metric for Passive House, and while this graph is a bit crazy at a glance, we're excited to see how these buildings perform throughout the year. Similarly, we're monitoring carbon dioxide levels in the common areas for health and safety, but also to see if there's a noticeable difference between the two buildings. During the week shown, the Passive House building had noticeably lower levels of CO2, but it's not enough data to confidently make that conclusion. Designing this monitoring system, I looked for any empirical studies regarding the reduction of thermal bridges in Passive House buildings and found none. So as a cost-effective method of addressing this pillar of Passive House construction, we installed temperature sensors on the outside of the building and also on the exterior wall of the adjacent inside apartment. You can clearly see how affected by solar gain the outdoor sensor is. And while this method isn't perfect and includes a lot of variables such as the tenant in the apartment with the indoor sensor, once we have more data, it'll be really interesting to see if we can draw any meaningful conclusions. Here's a nice picture of the property I've been discussing. The Passive House Park Avenue Green is on the left, with Morris Avenue Apartments on the right. Thank you so much for your time.
Hi, my name is Caitlin Travers. I'm a project manager with NYSERDA. I'm here today to walk through some of the Q&A with the project team, so let's get into it. First question is for Chris LeBron from The Rise. You mentioned in your presentation that having an aligned team and an engaged architect on the team were critical to the project. In what ways did team alignment aid the project, and how do you approach developing and building out this team?
Hi, Caitlin. Thanks for the question. It's a good one. And I have to say that I was not on board with Zenolith when the initial project team was assembled. But you know, it's always the critical piece to the puzzle. This RFP came out, and our principals, Andrea Kretschmer and Terry Belkas Mitchell, brought together, you know, the best team for this project. And I think it shows in what you're seeing here today.
Okay, great. Thank you. For Jim Garrison from the 76 project, can you expand on the concept of seasonal geothermal wells that are being used on this project?
Sure. We can you hear me? We had a challenge because these are 7-8 story buildings, so they the amount of photovoltaic energy that we could generate really wasn't enough to get us to net zero. So we wanted to use a solar thermal component. But the problem with solar thermal is we make lots of heat in the summertime, and we need it in the wintertime. So we searched around for a way to store that energy, and we looked at all kinds of things. Not many of them were viable for this kind of, you know, medium temperature water that comes off of the solar thermal loops. So what we did is we went to a specialist in geophysical science, and who's been developing geothermal well fields designed specifically to hold seasonal heat and to get a small rise in the surrounding temperature. We haven't gone through the full study for this yet, but that's the plan. So basically, we get enough heat below the building in the basement area that we can draw from it over the course of the winter.
All right, great. Thank you, Jim. Next question is for Matt Murphy from Bright Power. What is the plan to build out the thermal bridging analysis to collect and analyze more data? Will the entire analysis be between these two buildings, or are other buildings going to be included in that analysis?
Great question. Right now, it's just 4 data points or 4 pairs of data points on each building on the north side, east side, west side, south side. So to try and see like how does solar gain play a huge role in that. As I mentioned, it's definitely not a perfect analysis. right now we're just taking air temperature on either side of the wall. Ideally, you'd put like a strap-on thermistor on the actual structural members during construction. So, if we, maybe for some new construction projects, this was actually, I think, the only BOE grant for an existing building. But during, passive house new construction, an immediate lesson learned would be to, put some of those sensors like in the actual structural members themselves to see how effective the thermal breaks are. Because there are some lab results that, give some indication on how successful the thermal breaks are. But right now, the extent of our planned analysis is just to look at the two buildings compared to each other, maybe using some, like hobo data loggers, some temporary sensors to also compare surface temperature of the walls versus just like the air temp, on the outside versus the inside. So it's a very, very simple way of trying to give some empirical insight into like what the real life application of that passive house construction method is. So I'll definitely be reporting back after we have about a year's worth of data.
That sounds great. Thank you, Matt. Next question is for Sarah Beyer. Embodied carbon strategies that were mentioned in your presentation. Can you elaborate on what was done specifically for this project and which practices you see as most impactful and or more or less easy to implement for projects?
Okay, it's a big topic. I'll try to summarize. Most importantly, first starting with an efficient design, aligning things so you're not doing gymnastics that you don't need to structurally. You're minimizing your layout so you have efficient runs. That was definitely done here in this project. We also looking at transparency. So right now asking for the data on embodied carbon from all manufacturers of all products, but also specifically concrete, steel, sort of the big ones, the ones focusing on the higher material content categories. There's also some great products already out there from manufacturers that are really pushing the envelope, that are making statements that they're carbon neutral. There are some drywall products that are using a lot less water and making them lighter. That's actually a major manufacturer that's easily available. You can find really quickly. And also focusing on the type of insulation, of course, that we're using, moving away from plastic and fossil fuel products as often as we can, and doing a lot of research into just for future projects, thinking about storing agrifibers or bio waste materials that that's sort of like the future thinking about using, and these things are all, they're really emerging very quickly, but honestly, in the scope of how long we've been working with petroleum products, this is sort of a new emerging thing, and the whole idea of green chemistry is really coming online really fast, and it'll inform the space really quickly.
Great, thank you. Are there any of those areas that you feel like are particularly low-hanging fruit where, pretty easy for any project to implement them?
Yeah, well, definitely asking for transparency, your EPDs and HPDs, but also just really looking at the EC3 tool is great to kind of target what is available in your area in terms of low embodied concrete. And I think that's sort of something that, the concrete industry in New York City is kind of getting warmed up about. Those sort of the low-hanging fruit, asking for a carbon cure and positive and alternate SCMs that aren't necessarily slag or fly ash is also, that's actually not a low-hanging fruit. That's maybe the next thing.
Okay, great. Thank you, Sarah.
Yeah, one other comment to add in regard to that. Bright Power has been working on the passive house design with MAP on the rise. And there was some investigation into using mineral wool roof, which technically isn't typically terribly complicated, but it's an issue in terms of warranties and installers being comfortable and having a track record of using that material. And I think that's something the BOE award helps with, just making these construction and design and development teams really focus on these leading edge products and getting everyone in the industry to take a harder look and really try and use them.
You know, one thing I'd like to add on the concrete business, there's a fellow named Richard Ryman at Rutgers who has come out with a material called Cylindra, which is it's concrete, but it's carbon, it's CO2 entrained, and he's trying to get traction on this. I think this material, I think the rights to it were bought by Lafarge, but it's out there, and I think if we start specifying it, maybe we can start to move the dial on that. It has about half of the, it basically sequesters about half of the CO2 that the normal concrete produces in its production.
I realized I
Definitely an
also should
interesting
have
topic.
mentioned, sub-slab
Yeah, go ahead.
insulation too. You know, there is a 100% recycled sub-slab insulation. I see that they're kind of entering this conversation as well. I think they're an exhibitor as well.
Great. Thanks, everyone. Next question is for Avery at Bright Power on the Park Avenue Green project. Can you expand on the factors that were considered in reviewing unitized versus central ERV systems?
Yeah, and Abdullah might have some more comments. I wasn't involved in the project at that stage in the design, but typically there are several considerations with a passive house. Multifamilies more often tend to go with centralized systems nowadays, but there are a lot of reasons why you might go either direction. Unitized and distributed ERVs in each dwelling unit, maintenance becomes an issue. If it's a rental unit, having the building maintenance come into every apartment and clean filters periodically can be challenging, but not nothing that would prevent it from happening. Also, the number of penetrations increases, especially in a large building. So that's thermal breaks that need to be addressed, flashing costs, and centralized units. This building, Matt had mentioned, was I think the only DOE award that was awarded post-construction. So it actually is much earlier, only by a couple of years, but it makes a big difference than these other projects. And the number of effective and certified units were much smaller back then. So I think that drove some of the decision making as well.
Great. Next question is for the 76 project. It was mentioned that this project is in a historically disadvantaged community. Can you discuss how those factors play into the decisions made on the project and how incentives and tax credits are made available for projects in those communities?
You know, is Corey Jones here? I don't know if he's joined us or not. Doesn't look like it. The package of tax credits for the project are, they're being developed as we speak, and in collaboration with the CPC and a number of other agencies. It may be that this is a combination project where the apartment sales are used in combination with apartment rentals to bring down the cost of the units for rental. There's also there's a great deal of work going on with the limited equity co-op model on this, so that we have the ability to rent to people who can build equity without going through without having to pull the full down payment for this project. So that's coming from a lot of the ideas for that are coming from the Hackney Township. It's part of London, where the mayor of Hackney has developed these programs where about 25% of the rental rate is basically put into equity for each of the lower income apartments. So there's a variety of programs that are being considered at the moment, but I can't speak too much to it because it's being handled by others.
All right, well, thank you. Thank you, Jim. Next question is for Abdullah at Park Avenue Green. What lessons has the developer learned in constructing and operating these two similar buildings to LEED Gold versus Passive House, and how will those lessons be applied to future projects?
I mean, it's a good question. For the And as far as lessons learned, I mean, the reality is that for us, when we first took on this job, there's a lot of questions about what the benefits were of taking on a passive house job. And one of the early arguments was about, from a developer side, about cost savings related to utilities over the long term. And when we were first talking to the Bright Power folks, I think that's how the conversation started. But it's not so much that there are actual cost savings in terms of utility costs. It's more the question is a lot more nuanced than that. If you just were to do a simple assessment where you would take a look at what we pay in utilities at Morris One versus what we pay at Park Avenue Green, it's pretty much a wash. But the energy consumption is totally different, and the energy consumption over time there's a big difference to it. So I think for us, the main idea is we, and Matt and the guys at Bright Power know we focus a lot on our operations side, on our boiler plants, and we collect a lot of data on our own, and Bright Power kind of augments that as well. What our interest is, seeing that this is the future of where everybody's going. Actually, even more sophisticated than this is to see how this building really actually truly operates over time. And we've been learning a lot. And I think the question somebody had about the unitized ERVs is, for example, from us, just from a practical perspective, the unitized system was not a good decision. We have kind of falling apart on us on a regular basis. There's a lot of lessons learned, I think, from just managing these properties that are a little bit unusual. They're a lot more high tech than we're typically used to, and your standard, super is not going to be able to make a lot of the repairs that are needed. So for us, it's just a matter of living with the building over time. I mean, the actual development of the process, I can't say that the lessons learned are that much more different other than just the, construction details. But what we'll really learn is what happens over the next 5 to 10 years. And I think that that's what we're trying to invest our time in with Bright Power.
Have you developed any specialized training protocols? Sorry, Matt.
Training protocols. I mean, we kind of we had originally assigned some of our best supers to those buildings because we knew, technically there's going to be a lot involved, but really, I mean, just because of the nature of the technology involved, you can't really touch them even if you wanted to, or you don't want to touch them even, just from a warranty perspective. Particularly the ERVs, they've turned out to be particularly difficult to deal with and finicky. Not to mention the VRFs as well. I mean, there's not a protocol per se as much as, we spend a lot of time in the transition from once we complete construction. I stayed on the job for an additional 4 to 5 months. I was there probably every other day with the supers to kind of troubleshoot problems as they popped up. I normally don't do that. I mean, we're in and out of the job. There's a handover. It's about a week long and we go. But just kind of thinking through all the little details, I can't say that there's a particular protocol. It's just, you need a lot more time invested from the development team, making sure the transition to the property managers is smooth.
Yeah, Abdul, I just wanted to reinforce what you're saying. I mean, the industry needs to come up with more reliable, robust, low energy equipment. These VRF systems are they're a constant maintenance headache for all of us. So this is, and we don't have a good selection of integrated products where ventilation and heating, cooling, humidity control are taken care of. So we're really behind on this.
We just started looking at a product that's a kind of a packaged heat pump system that works a lot like a PTAC. I mean, even in the design, it's installed in the same way. I mean, we haven't put them out in the market yet. It's mostly in response to just electrification requests, but we'll see if that does any better. But the VRF is so installation heavy. If you're not watching the install with an eagle eye, or even just, simple human mistakes in one copper line, you lose a whole line of blowers in no time. So it's been since the first day we moved in. It's been a constant battle with the VRFs just to get them to work. And like I said, you have to bring a specialized technician. I mean, they're computerized systems. I mean, we replaced motherboard after motherboard. And the ERVs aren't particularly technical, but because we went with the unitized selection, I would heavily recommend that nobody did that. I mean, it's a real pain. I mean, they do go down, and when they go, you know, it's a lot more of a challenge than the ERVs that we have a lot of times on rooftops to deal with common space. I mean, we don't typically have as many problems with them. But the VRS for sure are not a sustainable solution as of yet.
Well, we're just about out of time, but we have one final question, and this can be for really any of the project teams. Two of the projects indicated that they were only certifying the residential portion of the building. Could somebody comment on why that choice is being made for these projects?
I can tell you about, with regard to the 76, which is a mixed building with a base first floor, which is has a variety of uses in it, that the energy for that first floor equals the energy for the 7 stories above it. So it's tremendously difficult to deal with the energy requirements for these other uses. And so it's quite demanding.
I mean, for us, the community facility was a small space. It was only about 4,000 square feet relative to the rest of the building. But also, at the time we went in for the certification, it was not fit out. So, you know, it was just it was a white box. So it had just very, very basic mechanical systems in it at that time.
Yeah, related to that. Sorry, go ahead.
Go ahead, Eric, go ahead.
Yeah, related to that, I think that's a typical situation that the tenant isn't known and typically have specific requirements separate from residential. And they're much more used to not having passive house systems. So that just makes it a bit more complicated to certify a whole building.
And for the rise, we have we're looking for a lot of glazing area, and triple pane storefronts of that size are still a little cost prohibitive for affordable housing projects.
Okay, well, great. Thank you everyone for your time. Thanks everyone for joining us today. I think this has been a great presentation, and yeah, have a great afternoon.